Okay, for today's lesson, we're going to be reviewing the metric system and how we convert within the metric system and the different types of measurements, whether it be length or um, mass or possibly even volume. And then after that, we're going to get into the introduction of one of the most important key points and parts of chemistry, and that is dimensional analysis, which I believe is going to be the key contributor whether you'll be very successful when we get to stoichiometry or not. To start with the metric system, if you see here on the screen, you have, I refer to it as the metric staircase. Some people call it the metric timeline or whatnot. And that kind of has the key prefixes that go along with the metric system. If you remember, we talked about why in sciences the metric system is used opposed to the American English version with you having to memorize many more conversion factors. In this setup, it's always by multiples of 10. So as you can see the two big arrows, as I go down the staircase, I always end up just multiplying by 10 for each step that I go. And as I go up the staircase, I always end up dividing by 10 for each step I go. And if that's how you need to do it, then that's how you do it. As you also can see down here on the bottom, another great thing with the metric system and knowing my prefixes and the steps that they're at is basically I end up just moving the decimal point left or right depending on the number of steps that I traveled. For instance, if I start here on the base unit, which is the base, which is gram, liter, or meter, and I end up going up here to this staircase, and it's the hecto, I ended up traveling 2 steps, which according to my arrow here I would end up dividing by 10. So say my initial number was 100. I end up traveling 1, so I divide it by 100, so that gives me 10. And I travel 1 more, divide by 10, which is 1. So if I started with 100 meters, 100 meters, I would end up saying that I have 1 hectometer. Same thing if I were to travel down. So say now I am, let me clean this up a little bit. Say now I'm starting with kilo and I have, say, 35 kilometers. How many, say, centimeters do I have? Well, I traveled 1, 2, 3, 4, 5. My own little slinky. I've traveled 5 steps down. So I'm going to end up multiplying my number 35 by 10 times 10 times 10 times 10 times 10 5 times. Or if I wanted to, I could quickly just say what's 10 to the 5th power and multiply that number by 35 if I had a calculator. The other thing I can do, which makes this nice with the metric system without even needing a calculator, is if we recall this down here again, and remember, we just simply move the decimal point that direction, however many spaces I moved, I went down 5 staircases. So if I put in my imaginary decimal place, I'm just going to move it 5 places. 1, 2, 3, 4, 5. Fill those in from your math classes you remembered, and my new answer now becomes 3,500,000. So I would have 3,500,000 centimeters in 35 kilometers. So hopefully we all remember that in the metric system. Now, what can we do with that? If we go to a couple practice problems real fast. We look at number 1. We have 36.52 milligrams. We got milligrams, we're going to grams. So if we go back to this slide, we are starting milligrams. There's where we're starting, and we're trying to get to there. So it's 1, 2, 3. 3 steps. So 3 steps, and we went to the left, we would just simply go 1, 2, 3. So 0.03652 grams. 0.0652. Okay. Here are a couple other practice ones you could more than welcome to do on your own if you would like. But like I said, we just wanted to quickly kind of review back to the metric system and converting within the metric system. What we're going to look at now is using different units, converting from, say, the metric to English and things like that. So as you can see here, we have ours, and it says basically 10 gallons is how many milliliters. So what's nice is they gave me a few conversion charts here. You also are going to be provided in class a metric in English conversion chart that is a paper that you actually can use throughout the whole year, and it's a pretty important paper that you'll want to save. In this setup here, we need to basically start with what we're given, which is 10 gallons, and I like to do these little T-charts that help out with my dimensional analysis. And we want to try and figure out what's the easiest way to get from gallons into milliliters. And if we come over here, we would look through here and we would find out that there's really no one-step fix. But what I could do is I can see gallons right here go into quarts. So I know that 4 quarts is equal to 1 gallon. And I want to put the gallon on the bottom so that when I do this math, these gallons end up canceling each other out. Now I'm in quarts, and if I see here, 1 liter is equal to 1.057 quarts. And once again, now my quarts will cancel, and I'm in liters. And then from there, we know that we have that unit here, which is 1 liter equals 1,000 milliliters. And if you do this correctly with the dimensional analysis, whatever unit you end up with in the upper right-hand corner of your chart is always going to be the units you end up with last, and that's what we were looking for. So we did it correctly. So in my calculator, I would just simply take 10 times 4, divide that whole thing by the 1057, and then multiply the whole thing by 1,000. Or in actuality, you could just take the 10 times 4 times 1,000 and divide it by the guy that's on the bottom. And if you do that all right, you get your answer. And if you recall, when your calculator gives you this long answer, it comes out to 37,842.9517, and so on. Now, what do I write? If you remember, we talked about significant figures, or sig figs, and we want to write with the exact same number of sig figs that we started with. So if we go back to our answer, or our question to begin with, you see that the only number you were given was this 10.0 gallons. And if you recall from the rules, because it's a decimal present, we started at the beginning, we stopped, and we counted, we had 3 sig figs. So I need to count this guy into 3 sig figs. So I start at the very beginning. We have 1, 2, 3. So I look at the 4. The 4 is less than 5, so I'm going to leave it at that. So I know I have 37,008. And then I don't want to include these as numbers, but I do want them to be the placeholders. So I'm going to make it go to zeros. I'm not going to add my decimal point, and I'm just going to then give me my proper unit, which was milliliters. So to be the right process, 10 gallons with 3 sig figs would be roughly basically at 37,800 milliliters through converting it from gallons to quarts to liters to milliliters. And that's how I would do a basics of my dimensional analysis. And like I said, this is one of those key rules or key concepts that if you can utilize and understand correctly, become very important throughout the unit, especially when we get to stoichiometry and we have more chemistry type of materials. As you can see, there are multiple things you can do. Now I can factor in two different types of units. So like in this setup here, I have 459 feet per second. Once again, I'm going to set my little T chart. And we're trying to get to miles per hour. So I need to try and figure out how can I convert feet into miles, and how can I convert seconds into hours. So if I look over here on my little charts, I can see that we have some feet into miles right here, 5,280 feet per mile. So if I go 5,280 feet per 1 mile, that will take care of my feet. And I'm in my miles. Now I just got to get from seconds to hours. And if we remember, there's basically 60 seconds in 1 minute, and then there's 60 minutes in 1 hour. So if I do a quick calculation, 60 times 60 gives me 3,600 seconds in 1 hour. So down here then I want seconds on the top, so the seconds will cancel. So 3,600 seconds per 1 hour. And now if I look at it correctly, the units that I have left are my mile and my hour, right what I wanted to be at. So I go to my calculator and I'm going to type in 459 divided by 5,280 multiplied by 3,600. So 459 divided by 5,280 times 3,600. Or like I said, you could have also went 459 times 3,600 and then divided that all by 5,280. And you get your grand total answer of 314.74285, and lots of numbers. Once again, we go back to the original problem. We have 3 sig figs here. So 3 sig figs means it's going to be the 314. We look at that 7. That 7 tells me to basically round up the 4. So it makes my answer at 315 miles per hour. So if you have something, say it, whatever, a flying projectile, some kind of object, and it's traveling at 459 feet per second, it's actually converting to something that's more understandable, since most of us have been in a car and we know miles per hour, mph. It's traveling at about 315 miles per hour, going quite quick. All right. Here's another practice problem you can try tonight. Come to class prepared with this answer possibly, and we will see about making sure that we get the understandings of basic conversions between metric systems and other types of measuring systems.